modify on the car and possibly remove and replace as we go through some of the labs. Now, the first job, the job of the suspension system of a car is to support it, to hold it up. So the part of the car that holds the rest of the car up is called what? What would we call that on a car? What's the part of the car that actually holds the car up as you drive it down the road? Not the wheels, not the frame, not the suspension. This is part of the suspension. It's not the tires. It's not the shocks. It's the springs. Your springs. It's okay. The springs are what hold your car up, because that affects ride height. Okay, if you change the height of your spring, that changes the height of your car. So ride height is affected by your springs. So your springs do the job of keeping your car up in the air as you ride down the road. They support the vehicle. They provide a cushion effect between the road and the car. They allow the tires to make solid contact with the road, and they maintain wheel alignment. So the springs are pretty important. The suspension system provides for improved vehicle handling and for cushioning road shock. It controls stability of the car when you change lanes. You turn or you brake. Compression or jounce occurs when the suspension system moves closer to the body. Compression is when the spring compresses. Jounce is when it comes back. Because any spring that is squished has energy in it. Okay? It's got to release the energy somehow, so it will want to push back. And that's what happens when you don't have shocks, or you don't have good shocks on a vehicle, and you hit a bump, and you have that compression. When it comes back, it continues to do that. And it doesn't really want to stop for a while. And that's when a car ends up bouncing down the road. That's a car that doesn't have good shock absorbers because they don't absorb that bouncing action. They don't slow it down any. That's your springs. So you could theoretically drive a car with absolutely no shocks on it. The car would be held up by the springs. You would get some cushion effect from bumps in the road, but you would be bouncing down the road constantly. It probably wouldn't be very safe to drive. Think about when you turn a car too. As you go into a turn, say you're turning to the left side kind of gets scrunched down, it compresses, and then the right side of the car though actually extends a little bit. So a car is always constantly moving. Its height is really always never perfect as you drive it. And there's some other parts that we're going to talk about here that also are in effect when that happens. Flip the page to 552. When you guys do this whole homework, if you haven't started this yet, really important that you read this first section. What I suggest you do is read it completely. Don't pull out your questions. Don't look at the questions. Read section 1 first. There's a lot of information in here. I think you should read it first. Then you can go ahead and start writing the questions and then searching for the questions. The basic parts of a suspension system, I can guarantee you this will be on a quiz. The basic parts of a suspension system are springs. So this is something you'll want to write down if you haven't got your notes started. Springs, shock absorbers, anti-sway bars, control arms, ball joints, axles, and wheel bearings are all part of a suspension system. Springs, it's right in the book. That's why you should have your book open to read along with me. Parts of a suspension system are springs, shock absorbers, anti-sway bars, control arms, ball joints, axles, and wheel bearings. It's in the first paragraph on page 552. That will be on a test. Those are all the basic parts of a suspension system. But you got to understand that some vehicles have different suspension systems than others. So there are additional parts that I haven't talked about yet that may be on one vehicle, but not on another. We're going to take a look at them here in a minute. So as I talked about, springs support the body. Shock absorbers control the spring action by dampening the spring oscillations. Anti-sway bars are a type of torsion bars. Everybody know what a torsion bar is? Yeah. What's a torsion bar? It's got a spring on the end that adjusts the magnetic. It does what? Say it again. It adjusts the magnetic. It's a bar. It's a bar. And it tightens the spring before you put the bar up. Okay. So basically, go ahead, Austin. Yeah, basically it is a round bar, long, that twists to provide a spring action. I know some of you are going, oh, no, I don't know. You guys have all seen a typical coil you understand that when we put a force on a coil spring, it compresses, you know, and then we'll go the other way too. Well, what we're talking about here is this is a torsion bar. It does the exact same thing as a spring. If I put pressure on this thing in a certain way to try and turn it, the bar will twist and offer resistance to that downward force. So on some cars, they use this instead of that. And it is just like that. It attaches in the front of the vehicle and works towards the back. It's called the torsion bar. They used it back in the 60s on a lot of cars, and then it came back in the 80s on a lot of vehicles. Remember bringing my truck, I could show you my torsion bars on my truck. My truck has torsion bars. There's no coil springs on it. It uses a bar. The nice thing about these is they're adjustable. So I can adjust the height of my vehicle slightly, not a lot, with these. Where these are, once they're in there, that's all you got. You can't adjust those. Not a lot. You don't get a lot of, yeah, like that. Just a little bit. How much? 2.5? We got 2.5 inches out of this, so they're adjustable. So it's just a different way, a different type of spring. It's called the torsion bar.
Does that affect the
right height? Yeah. Well, yeah, it does affect your alignment, going higher or lower. Yeah, a little bit.
What I mean, like, does it put any more pressure on any other part?
No, I mean, the higher you put a vehicle, when you go into turns and stuff, that changes the center of the weight, you know, distribution. So, yeah, it might be tippier or something, but that's it. It doesn't really affect anything. If you start raising a vehicle really high, then you start to affect a couple of things. A, your steering. You know, the things that you guys have been looking at, those U-joints, those couplers, those get affected because those can only adjust so far for height. So you can affect that. And if you have a drive shaft, if it's a rear-wheel drive you do, those have an angle to them as well. So if you raise it up a lot more, the angles become more severe and you start having U-joint problems. So there's things you can do within reason. And if you want to go real high, you have to make adjustments for those things. Question. Anti-sway bars. They're a type of torsion bar that connects the lower suspension to both sides of the frame of the body. These bars prevent the body or the frame from leaning too far in turns. That's what a sway bar does. If you got a performance car, you probably have a sway bar in the front and in the back. Not all cars have them in the back or the front, depends on the car. Control arms position the wheels on the frame or body and maintain wheel alignment for the frame or the body. There's pictures of control arms on the next page in blue. Ball joints enable suspension parts to pivot and rotate. Axles provide a positioning point for the wheels, and they serve as a center point for wheel position and rotation, and wheel bearings enable the tires and wheels to move smoothly and freely down the road. Springs, different types of springs. We've got two of them up there, coil springs and torsion bars. Anybody know another type of spring in use? Yeah, here's this one. So,
Air spring.
this is called a leaf spring. Who else? Somebody said another type of spring? Air spring. We usually use some type of bag in there. Okay, the important point here, I'm sure it's going to be on a quiz. Springs are used to support sprung weight. This includes the weight of the body and or frame, engine, transmission, cargo, and passenger. That's called sprung weight. The weight that the spring holds. Unsprung weight refers to the weight that the springs do not support, like your wheels, tires, brakes, lower control arms, and drive axles. Basically anything below the spring is unsprung weight. Weight that's there, but the spring's not supporting. So the spring supports everything that's above it, which is the body, the engine, the transmission, you, and anything inside the vehicle. So remember those two terms. sprung weight and unsprung weight. Just remember that unsprung weight means anything the spring is not supporting. Vehicle makers try to make unsprung weight as light as possible. This is why a lot of vehicles come with aluminum parts to them. Aluminum frames, aluminum lower control arms, aluminum wheels. Coil springs is a spring steel rod wound into a coil. The rod can be the same diameter from end to end, giving the spring what they call a constant spring rate. Now you get into a little dynamics. When you start to race and things like that, spring rates become important because the spring will act differently when you push it down. If it's the same diameter all the way around, it has a constant spring rate, which means the harder I push, the harder this pushes back. That's a constant rate. It's the same no matter how much I push, it kind of stays the same. But they do make coil springs that have different size coil diameter through the springs. Those are a variable coil spring. We use them a lot in cars today, which means that when I first start to push, it pushes back a certain amount. But if I continue to push harder, it will change how much it pushes back. It will react in a different way. And that's called a variable rate spring.
What would that do now?
Depends on what you want it to do and how much weight you want to affect it. It could be almost anything you want. Over light bumps, maybe you want the spring to be very hard and not oscillate very much. But as the harder you push down, maybe you don't need so much pushback. It all depends on what you're looking for. A lot of racing applications, off-roading, Baja stuff, they do all kinds of crazy stuff with springs to tailor it to exactly what you want. So it depends on the situation. All on how you make that spring. Leaf springs, spring that consists of a single or multiple spring steel band. That's what a leaf spring is. We're going to take a look at them on the truck in a minute. There are mono leaf springs, which is just one leaf, which they have. They make them out of steel and or some kind of composite material, some plastics. There are actually some plastic springs out there in some vehicles, mono springs. And then they have multiple leaf springs, like we're going to see on the truck, that have multiple leaves in it. We talked about the torsion bar. We talked about the air spring. It's just a cylindrical bag full of air that can automatically adjust height, which is kind of cool for some cars. Air suspension is movable. So if you put a lot of stuff in the back of a car or a truck, the compressor turns on automatically and will raise the back of the car so it's level again. So air suspension is kind of nice and stuff like that. Gives you a better ride because it keeps the car stable. They use sensors on those too, by the way, that monitor the height, monitor the movement. Very similar to the engine, where we monitor movement of the throttle, called the throttle position sensor. That type of sensor is called potentiometer. It's the same sensor we use to monitor height on air suspension systems. We use the potentiometer to measure how much change it has, high or low. It's the same sensor. Shock absorbers, dampened spring action, allows the spring to compress and rebound at a controlled rate. It just controls how that spring rebounds, comes back. That's really important. We have to control that, otherwise the thing will be bouncing down the road. If you've ever had a bad shock taken off a car and felt it and tried to push the shock in and out, if it was really easy to do, that spring was really bad, or that shock was really bad. It allowed the spring to just bounce. You want a shock absorber that you can push in, but pulling it out is a lot harder on a new one. If we ever get a new one, I'll show you what we're talking about. A lot harder to pull out than it is to push it in. Okay, I want to get you up out of the chairs for a second. Let's go over to the car here, the truck, I'm sorry. First thing I want you to tell me is what type of spring is this truck using in the front of it? In the front of it.